Well, hello everyone, thanks for your time. My name's Dominic. I'm a principal consultant and director at First Response. I've been dealing with Active Directory since 1998, curiously, just before it came out. And I've spent a long time doing cyber forensics and digital security in various different forms. The last few years, I've been working very much, mostly with Jim and his team, doing audits and assessments across Active Directories. And we developed a very specific audit that we've used in essentially more than 250 different organizations, many of them NHS trusts, that allowed us to see the patterns of behavior across all of these different, quite disparate implementations, and understand the patterns within there, the things that people were getting right and very much the things that people were getting wrong. So the patterns that we discovered while we were looking through all of this data allowed us to classify the issues that we were finding into what we call point fixes and structural changes. Point fixes tend to be the smaller things where you can generally flick a switch to fix a problem. Something like turn off old NTLM protocols, disable old server message block protocols. A lot of it is focused around that area. Reset Kerberos baseline passwords so that they can't be used for persistence by an attacker. So these are the point fixes, small things. Sometimes they require a small project to to check the environment and make sure that flicking the switch isn't going to blow anything up, but generally they're small independent issues. But there were a lot of issues that we came across, issues around the separation of user and admin authority, having too many higher authority identities within the system, the littering of higher identity accounts all over the place. And all of these together, we were able to group together as a structural flaw, a structural change. So a structural change is required to fix these things, because to fix them, you need to fix a whole bunch of things simultaneously. And only when you fix enough of those things together do you actually get a security improvement. And each step along the way does give you these little marginal security improvements, but it's only when you get to a certain level, a certain structural stability, that you've actually got a really powerful change in the system, and a change that will last and is maintainable. A lot of this is based around the simple idea that there is a flaw at the heart of the Windows system. And this flaw is to do with caching. Every time an account logs onto anything within the system, that account is cached on either the workstation or the server or the domain controller, because generally we split the network into workstations. You can see the bottom left of the diagram, servers in the middle on the right, and domain controllers as the controller systems above them. But whenever an account it logs on, a cache of that account credential is left behind. You've all come across the pass the hash attack, or at least heard of it. This is the ability of an attacker to lift credentials and then use those credentials. The problem we have here is that credentials of all sorts, client level credentials, server level credentials, and domain credentials, are littered across all of the machines in a Windows infrastructure. It's always been this way. It's always been exploited by attackers, but it's quite hard to deal with for a number of reasons. So it's very rarely dealt with. So the keys existing, as I said, in different levels. There are client keys, which would allow an attacker to access user information, the area of shared data that they have access to, and and various other low grade functions of the system. If an attacker can get hold of server keys, they then have access to the SQL databases, the full file shares, not just the little pieces of file shares that the users can see, and making exfiltration of data very, very much easier. They also gain access to the support systems for the network, things like DHCP and in some cases DNS, which allow them to create persistence within the network, to connect and manipulate the way the network functions. If an attacker can get hold of the domain keys, they basically have full control of the entire infrastructure, not just the Windows infrastructure, the whole of the infrastructure, because all of your underlying infrastructure components, things like your VPNs, your switches, your routers, your proxy filters that control network access, and all those other devices, invariably connect into the Active Directory for their management identities and to determine user access. So getting hold of the domain level identities in Active Directory actually gives an attacker pretty much the entire infrastructure. Sadly, getting into a system and escalating through a system are actually depressingly easy. Getting into a system is, and as Jim was talking about, is getting easier and easier, partly because of the advent of IA, but also because attackers are just getting more experienced. Their code is better, their processes are better, and they become much more professional about it. So you get into a workstation by one of various mechanisms: phishing, more commonly spear phishing, targeted phishing, less commonly direct intrusion, but it still happens. Multi-factor authentication can help, but it's not perfect. Once you get into a workstation, you'll see that a client admin account can be lifted. There's always a client admin account on every workstation. And once that's been lifted, an attacker can then move to all the other workstations in your environment, and they will do this in code automatically, very, very fast. They'll zoom around the client base, and finally they'll find a server, they'll find a client that a server admin has logged onto. They pick up those credentials. Now the attacker is a server admin. They go straight to the servers and they move around the servers until they find a server that a domain admin has logged onto. Now the attacker is a domain admin and they own your entire infrastructure. Like I said, depressingly easy, both get in and even easier to escalate, because the credentials that the attacker needs are just sitting there, lying around the system, waiting to be picked up. There is a defense against this, and it's a damn good one, which is zoning. So the idea of zoning is that if the credentials, the server and domain admin credentials, are simply not there, they can't be lifted and used by an attacker. They can't be stolen by an attacker when an attacker breaks into a workstation. Why doesn't everyone do zoning? It's difficult. It's difficult to organize. The structures required for it are not as difficult as you'd imagine, but the transition to it is quite difficult. And to do it at very low risk, to do it fast enough to be effective, and then to enforce it, it's actually quite a terrifying piece of work for internal administrators. It's a rather specialized piece of work. But the need for it, and so you can see when the work is complete, you create a situation where you have administration accounts or accounts with administrative power bandied into specific zones. There will be no domain admin or server admin accounts in the client base, anywhere on the client base, so the attacker can't pick them up. If an attacker by some fluke managed to get a server credential and get themselves into the server layer, there will be no domain admin credentials in the server layer for them to pick up. Very simple concept, and very, very powerful once correctly implemented. And the need for this zoning is actually supported by multiple agencies around the world. This is an extract from a recent document, which was a collaboration between all of the agencies that you can see on the screen there. And the first page of this document, the big grey paragraph on the first page of the document, is the best way to protect Active Directory is to protect the keys, and do that by zoning. And it talks there about zone 1, but it also mentions it talks about zone 0 as the primary zone. That's the domain zone, but it also talks about tiers 1 and 2, which is the server and client zones. Just a little aside from that, because the document talks about MFA and PAM, and we're all very aware of those technologies. It's worth noting that MFAs and PAMs, privileged access managers, are more front-end devices. They deal with managing the authorization of accounts. Certainly that's what MFA is about, hardening the authentication. And PAMs may have some authorization capabilities, but again, their strong point is focusing the login, session recording, centralizing audits, giving you bits and pieces of validation, but role-based authority with administrative zoning actually bakes that validation into the Active Directory itself. So even someone who can evade a PAM or evade MFA will still have an account that is zoned by the Active Directory in the Windows infrastructure natively. It's a very powerful layer of defense. So back on track. How do you get to administrative zoning? Administrative zoning requires a number of steps, and each step has its own benefit, its own security enhancement. But as I said to you before, you have to get a certain way along this path before suddenly all of these things that you've done click into place and start to form a really, really powerful defense. So the first step is to separate admin accounts from user accounts. So that your administrators are not opening emails and browsing the web using an admin account. It's a very obvious separation. We've been used to that for years now. The advice has been there for donkey's years now, and most people do it. The The second step is to implement role-based authority. Again, these concepts for role-based authority have been around for ages, and many people have role-based authority designed into their systems. Some of it works, some of it doesn't. But the advantage of role-based authority is that you can now scope your admin accounts, and it creates the possibility that you can limit your higher authority memberships, those domain admin accounts that are so powerful and so dangerous to have floating around the system. Once you have enough role-based authority in place and it's working properly, you can actually empty your domain admin accounts of all, not only the admin accounts that are in it, but the service accounts that are in it as well. And that's a bit that people stick on very badly. The people's willingness to change the powers associated with service accounts is very low, because it's a very frightening thing. Changing those powers may change the way the service reacts, may cause a service outage. So it's something people are very loath to do, but it's profoundly important. When you get to this point, you should be able to minimize your total number of domain admins down to, a maximum of 5 actual people, 5 administrators, and maybe a couple of services that really do things with the Active Directory, but don't really need, but need specific powers. Most other services just need the odd power here or there, or the ability to manipulate a server that they're running on. Once you've minimized the higher authorities, you've taken a huge step towards strengthening the system, and that minimizing the higher authorities allows you to put a domain boundary in. It's what allows you to collect all of the strength of these 3 components together and make them really powerful. The next step on from that is to separate these authorizations and authorities onto different accounts. So you have anyone who's going to do domain admin work has a domain admin account, but they also have a server admin account. And 90% of the time they do their admin work with their server admin account, and they only ever use their domain admin account to log on to domain controllers. Similarly, you want to separate server admin from client admin onto different actual logins, so that anyone who wants to do client admin work actually logs on with a client admin account. And finally, once you've separated client admin accounts from server admin accounts from domain admin accounts, you put boundaries in the middle of them, technical blocks that actually prevent those accounts from logging on to zones that they're not supposed to log into. And that's when you get right up into the high end of this security, and the system becomes able to protect itself very, very strongly. The Active Directory can do all of this stuff natively. The technology for this is in the Active Directory. There's no software required. It's just a reconfiguration, a layer of security that you need to put right at the top of your Active Directory architecture, which then flows down onto everything in there. This point, around about 6, where we've separated out the domain admins, and we can put in a domain boundary, the higher boundary. That's the minimum place that any organization really needs to get to. But even then, you get so much stronger if you take it the full distance. Most organizations think they are about here. They think they've minimized the higher authority membership. But generally speaking, when we go and actually do the audit, when we say how many domain admins have you got, and they say, oh, we've got 5, what they mean is the people, not the actual accounts that have domain admin power. So generally what we're seeing is 30, 40, 50. We've had 250 as well that we came across early in our run of audits. So most organizations think they're about there, but actually most organizations are about here. They have some role-based authority in place. They've done some removal of separation of administrators from domain admins and higher authorities, but it's incomplete. They still have far too many domain admins, and it's not normalized. It's not a normalized working pattern to have everyone with a role-based authority separate from domain admins. Tragically, 2 of the audits we did, the first 200 audits that we did, were at this level. They hadn't actually separated admin and user capabilities at all. So even though that's been a marked step for a long time, it's still in place out there. So how do we do this natively? The first thing to recognise is that these changes, this implementation of role-based authority and zoning is a fundamental requirement for the Active Directory. It's so fundamental, in fact, that exactly the same architecture to present these capabilities can be used in every Active Directory that exists. And I say that quite comfortably because I've been doing this for 25 years and I've used iterations of this technique in the whole of that time. More recently, we've just done a more focused, streamlined version of this and have implemented in 10 organizations in the last year, and it's working beautifully in all of them. So any organization can benefit from this, unified, standardized, high-level structure. But you build it using the directory's own components: organizational units, groups, GPOs, group policy preferences, and a set of access control for delineating role-based authority. It's standard Active Directory technology, but you just forge it correctly. You format and configure it correctly to produce this amazingly strong result. But all organizations are not the same, and every organization needs to be, when you put this in, every organization needs to be cleaned up. And there are always things that are specific to individual organizations, specific security controls that you have to modify and present in a slightly different way, because you've all seen different Active Directories. They can be wildly different in their presentation, and the application sets and service sets that organizations use are also wildly different. In this particular example, this was a trust with 20,000 users and 700 servers. There were 247 domain admins when we started. There were 5 admins and 4 services when we finished putting in the domain boundary, the higher of those 2 boundaries. When we surveyed the server base, there were 385,000 connection points between users and server administration. So there were 385 potential server logins that we had to assess, handle, make sure they work. And we have to, when you do this work, you have to pick out what is necessary, what is functional, what is dangerous, and what is just legacy. And you get rid of the legacy, mitigate the dangerous, and maintain the necessary. Because if you go through this process and you don't maintain the necessary functions correctly, that's when you start to cause user issues. And we can do this very, very precisely. We've developed analytics over the course of the last year to do this, so we know that this can be done, if it's done correctly, in a 3 to 4 month timescale, depending on kind of involvement and buy-in from the trust, and with very little of the impact on either the administrator and certainly not on the users within the environment. So as we've been doing these projects over the last year and a half, we've discovered that we're able to do this with very, very low risk, as long as you understand what data to pull out and how to manage and manipulate that data. And as I said, there's a cleanup required as well. In that same place, we analysed 40,000 access controls and cleaned out 15,000 of them that were rogue, legacies, dangerous because they presented privilege elevations and so on. So there's this very distinct pattern to the work, to building one of these structures. A core structure that presents these role-based authority functions, and that needs to be tailored a little to the specific environment. So here we end up. If you put role-based authority and administrative zoning in place, you end up with an infrastructure that is massively harder for an attacker to move through. So hard, in fact, that the chances are most attackers will just give up unless they really want the prize in your environment. But you're also making it so much harder for them to move through the environment, having taken away the standard pivoting capability, that they then have to prod things in the environment. They have to do much more work, a lot of it manual, because there are less automations for the other techniques. And this slowing them down, making them do more, making them behave more weirdly, that's the kind of thing that monitoring processes will spot. So the monitoring processes that Harry is going to talk to you about in just a moment will have their functionality increased and enhanced by a good foundation, because a good foundation will force attackers to behave more strangely, giving the monitoring capability more chance to see it. The strong foundation gives the directory a very much stronger resistance to attack as a result, but it also gives it resistance to uncontrolled change and administrative accident. All this higher work that we do, the higher authority boundaries that we put in place, mean that only a very limited number of people can substantively affect the overall security of the system. But like everything else in the technology universe, this foundation is built on a set of rules, and rules that can be broken, rules that may change over time depending on installations and upgrades or an attacker. So it's very, very important that the various attributes and configurations that form this foundation are monitored correctly to keep them safe, to keep them sound.